Point your finger at the sky tonight. Find a tiny gap between two stars, a patch of blackness so small that if you held a single grain of sand at arm's length, it would cover it completely. To our eyes, and even to our best telescopes for decades, that spot was empty. It was unremarkable. But in July 2022, the James Webb Space Telescope, a machine the size of a tennis court with mirrors coated in real gold, stared at that exact spot for just 12 hours. When the data came back to Earth at 3 in the morning, the rooms at the Space Telescope Science Institute went quiet, because inside that tiny grain of sand were 10,000 galaxies. Every smear of red light, every tiny spiral, every glowing smudge was a city of hundreds of billions of stars. But as astronomers zoomed in on the oldest, reddest dots in that image, the excitement turned into a quiet scientific panic. They found something that shouldn't be there. They found 6 galaxies that were so massive and so mature, they effectively broke our understanding of how the universe began. They've started calling them the universe breakers. Tonight, we're going to talk about why these 6 dots are forcing us to rewrite the history books, and why the first draft of our universe might be completely wrong. To understand why these galaxies are such a problem, we have to look at the instruction manual for the universe. Scientists call it Lambda CDM. For decades, we believed the universe was a slow builder. We thought that right after the Big Bang, matter was spread out nearly smooth, like a thin fog. Gravity is a patient force. It takes time for that fog to pull together into tiny ripples, then into small clumps of dark matter, and eventually into the first few stars. This is called hierarchical structure formation, basically the bottom-up method. Our models were confident. They said that in the first few 100 million years, the universe should look young, messy, and sparse. You shouldn't see a finished galaxy any more than you'd expect to see a fully grown oak tree on a patch of land that was just cleared yesterday. The math was clear. Building a galaxy like the Milky Way should take billions of years. But then, Webb opened its eyes. How does a telescope see the past? It sounds like science fiction, but it's just physics. Light travels at a fixed speed, about 186,000 miles per second. When you look at the sun, you see it as it was 8 minutes ago. When Webb looks at a distant galaxy, it sees light that has been traveling for 13 billion years. As that light travels, the universe expands, stretching the light like a rubber band. This turns visible light into infrared, heat radiation. Older telescopes, like Hubble, were essentially blind to this stretched light. Webb was built specifically to see it. And what did it find in the first 500 to 700 million years after the Big Bang? It found 6 candidates that weren't messy clumps. One of them appeared to have as many stars as our modern Milky Way. Imagine walking onto a construction site where the workers only started laying the foundation an hour ago. You expect to see piles of dirt and a few bricks. Instead, you find a 5-story apartment building, fully wired, with people already living inside. That is the universe breaker problem. These galaxies are too big too soon. You might think, okay, so things just grew a little faster. What's the big deal? The deal is that physics has a speed limit for growth. To build a galaxy, gas has to fall into a dark matter trap and cool down. If the gas is too hot, it won't collapse into stars. This cooling process is governed by atomic physics that doesn't bend just because we want it to. Then there's efficiency. In our neck of the woods, galaxies are actually pretty lazy. The Milky Way only makes about 1 or 2 new stars a year. Most galaxies only turn a tiny fraction of their gas into stars because the heat from new stars and supernovae actually pushes the remaining gas away. It's like a built-in brake on growth. To reach the mass Webb saw, these early galaxies would need to be converting gas into stars at nearly 100% efficiency.
They'd have to be forming stars hundreds or thousands of times faster than anything we see today, and they'd have to keep that pace up for hundreds of millions of years without ever taking a break. It's not just one weird galaxy either. Webb found a pattern. It found the cosmic vine, a chain of 20 massive galaxies stretching 50 million light-years, already organized when the universe was just 15% of its current age. It found protoclusters, groups of galaxies already bound together by gravity just 700 million years after the start. The gravitational skeleton of the universe had a massive head start. So how do we fix the broken model? Scientists are looking at two shady characters, supermassive black holes and dark matter. Webb found these things called little red dots. They're tiny, compact galaxies that seem to have a feeding supermassive black hole at their center. But these black holes are way too big. Some are 1 billion times the mass of our sun when the universe was still a toddler. If these black holes grew that fast, they might have seeded the galaxies around them, acting like a cosmic turbocharger for growth. Then there's dark matter. We know dark matter provides the scaffolding for everything we see. If the dark matter in the early universe clumped together faster or more aggressively than our models say, then the galaxies inside those clumps would have grown faster too. Perhaps the seeds planted by the Big Bang were just a little bit bigger than we thought. If the ripples in the early universe were more extreme, structure would have collapsed earlier and more violently. We sent a telescope to look at the beginning of everything, and what it found was a universe that had already been busy for a long time before we thought it even started. The standard model of cosmology isn't dead, but it is under immense pressure. It has a door that we assumed was closed, and Webb has kicked it wide open. This is how science works. We build a model, we test it, and when the universe refuses to follow our rules, we don't ignore the data, we change our minds. We are currently looking at the first draft of the cosmos, and we're realizing we missed a few pages. It's a reminder that no matter how much we think we know, the universe is always vaster, older, and more complex than our imaginations. We are just a few pages into the story. Thank you for joining me on this journey to the edge of time. If you want to stay inside the discovery as it unfolds, hit that subscribe button. Keep looking up. The next impossible discovery is already out there, waiting to be found. Good night.